how to build an 8-bit computer in Logisim-Evolution. So in this episode, we're going to be covering how to build the ALU, which stands for Arithmetic Logic Unit, and that'll be what's doing the calculations of our computer, so the mathematics, addition and subtraction. We're not going to be doing multiplication or division because that's a bit more complicated, but yeah. So I've already made a folder here called computer tutorial, and then let me just delete this circuit. So yeah, in this episode we're going to be making a half adder, and then a full adder, a 4-bit adder, and then chaining two 4-bit adders to make an 8-bit adder, and then adding a subtract button to make it be able to subtract, and that'll be our ALU. So I'm just going to create a new circuit called half adder. That's going to be our first circuit. And our half adder will have two inputs, A and B. So you can just name your pins by double clicking on them and then typing. So for our half adder, we're going to need an XOR gate, which looks like this, and an AND gate. And then A and B go into the XOR gate. You can just put the pins to the inputs here and drag them back to make wires, or you can drag it manually to make wires as well. And then A goes into the AND gate here, and B goes into the AND gate here as well. And then the top output will be your sum. So you can just pull that back. I'm going to name it sum. And then this will be your carry. And then to save your circuit, you can just Command S, and that'll save your circuit. Or you can go to File, and then there's also a save button there. Yeah, so we can test if this works. So 1 plus 0 should just be sum. Any one of them should just be sum, but both of them should just be carry. So yeah, that's working. That's our half adder. And then we can make a new circuit called full adder. So this will be full adder. So for a full adder, we're going to need two half adders. And this time we're going to have 3 inputs. So 3 inputs, two of them are the same, so A and B are the same. And then we have a new input called carry in. I'm just going to name it C in. Okay, so what we have to do is A and B again both go into the first half adder. Like this. There we go. And then for the second half adder, the sum goes into A of the second half adder. And then the carry, we're going to have to take an OR gate, which looks like this. And then the B input is just going to be the carry in of this. And then your sum is this. And then you have to have an OR gate with both of your carries like this. And then you can take both of your pins. So your top output will be your sum, and your bottom output would be your carry. Okay, so we can check if this works. So either any one of them should just be sum again, both of them should be carry, and then all 3 of them should be both of the outputs. Yeah, and then just carry should also just be sum. Nice. So that's our full adder, comprised of 2 half adders. So I'm just gonna save this. There we go. And then we're gonna make one more. Actually, we have 2 more after this because we have to chain them together. So our next one is 4-bit adder. We're gonna make our 4-bit adder by chaining 4 full adders. So the wiring gets a bit more complicated here. There we go. So 4, and then we're gonna have 8 inputs because 2 4-bit numbers. I'm just gonna 3, 4. you can just copy and paste it to make it faster. And then you also have a carry in input. So your carry in goes to your carry in of here, but we don't just wire these two to here and these two to here and so on, because you want to add these two numbers together. So the least significant bit of this will be going to the B of this, and you want to add the least significant bit of your first 4-bit number to the least significant bit of your second. So this will come back down here. And then same for your second least significant, like second most least significant bit, if that makes sense. And then with all these two. Three. And the final one is this one. And then for the carry-ins are just going to be the carry-out of the previous adder. So it's going to be like, that's why it's called like chaining it. It's just like a flow adder. And then the sum will be your output. So you just carry, and we're going to have 5 outputs because there's going to be 1 carry out. So this comes here. And you can just try this back. Okay, and then same for these ones. And then you have to have 1 carry out output. Okay, there we go. So this should be your full 4-bit adder. So we can try adding 1 plus 1 should be 2, because that's 2 in binary. And then you can do 6 plus 5 should be 11. 1, 0, 1, 1, so that's 8, 2, and 1. So 8 plus 2 is 10, plus 1 is 11. And 6 plus 5 is 11, so that is right. And then carry in should just give you 1. And all of them should give you all of them. Nice. And if any of the addition goes over 16, carry should always be included. So like, if you get 8 plus 8, that's 16, should just be carry. I'm actually going to name the carry pin. Okay. Okay, so let me just save this. So this is working. Now our next one is going to be our ALUs. That's our final one. And for this, we're going to need 2 4-bit adders, since we have an 8-bit ALU, 8-bit computer as well. So for this, we're going to have 16 inputs. So it's going to be a lot of inputs. I recommend just copy and pasting it if it takes too long. So I'm going to separate them into groups of 8. So this is the first group of 8, second group of 8. And then 1 carry in input, but this is not actually going to be our carry in. This is going to be our subtract button. So I'm just going to name this subtract. Yeah. So that's basically it for the inputs. And then carry is also chained like we did for the full adders in the 4-bit adder circuit. And then I'm just going to add the outputs. And there's also going to be 1 carry out output for this as well. I'll have 1 extra. And this comes out here. So that's all of our outputs. I'm actually going to connect these two because that's technically how it's supposed to be. And then how we're going to do this is, since we want it to subtract as well, we're gonna have to have XOR gates for every single B input, because we're kind of inverting the B inputs but not really, so it's kind of confusing. So we're gonna need 8 XOR gates. So I'm just gonna take 4 of them, copy and paste it. There we go. Take all of this, I'm gonna move this down just to save space. So our subtract button should be going into the bottom input of all of these XOR gates. Just like this. You can just do it like this, it looks much better. So this goes into here, and then all of your B inputs from here also go into the top input of each XOR gate. So this one comes down here and so on. So just keep wiring these. It looks better if you don't overlap the wires. So that's what I'm trying to not to do. So overlap the wires. And then the subtract wire also comes to the carry in. So now all we have to do is wire up these outputs of the XOR gates and these 8 out inputs into the actual adders. So what we have to do is these top, since you're adding these together, we have to use the same logic that we did for a 4-bit adder, is instead of putting all 8 of these into here and all 8 of these into here, since we want to add them together, we want to put 4 of these into here, 4 of these into here, and then the 4 most significant bits of B into here, and 4 most significant bits of A into here. So I'll start with A. So, okay, I shouldn't have started with the least significant bit. Makes it kind of confusing. I'll start with this one. So the first 4 bits of A come down here into here, and then that's it for A. And then the most significant bits of B also come here because you're adding the 2 numbers together. I'm gonna just keep it as clean looking as possible. That's 4. And yeah, that's your first. And then your second one is going to be all of the least significant bits from both of them. Three, 4. And then same for the outputs of the XOR gates as well. 2, 3, and then whenever we turn on the subtract button, it should also turn on the carry just to show the carry out, just to show that it's in subtract. Okay, so that's it for 8-bit ALU. So we can test it out now. Let me just go into pointer mode. And then, so 1 plus 1 should just be 2. Cool, that's right. We saw that in the last one too. And then, let's do some bigger number additions. 64 plus 64 should be 128. So that's 1, 2, 4, 8, 16, 32, 64, 128. So that's good. And then 128 plus 128 should just be carried, because that should be technically be 256. So let's try subtract mode. And let's subtract 3 minus 3 should be 0, and then the carry out is on because it just shows that subtract is on. And then let's do one big number, and it should be good. So 128 minus 64 should just be 64. That's right. And then 192 minus 64 should be 128, and the carry is just on because it shows subtraction. So yeah, that's basically it for the 8-bit ALU. Thank you for watching, and bye.